Okay, the workload here on this Friday is going to be a little bit light for both the group that's here and the group that's at home, because I want to make a clean break with this week as to how to name and write chemical formulas for binary ionic compounds. The ones that have two things in them. Let's get that down good. And then we'll do polyatomics. I'll do lessons over the weekends on polyatomics. So this is where we left off. And again, these aren't on your paper. These aren't ones we're going to look at this year. Next year, that'll be different. Okay, so let's go to the questions on page 571. But we're not going to do all of them. So if you're watching the video and you're picking through here, we're only going to do the questions that were with binary. There are some that have polyatomics in them. I saw one with a hydrate. We're going to kick those down the can and do them at a separate time and group all the binaries together so there's less confusion. Okay, so number 20 says write formulas for the following compounds: potassium iodide, phosphorus pentachloride, magnesium hydroxide, aluminum sulfate, dichlorine heptoxide, and calcium nitrate trihydrate. Well, there's two other things in there. You have some covalent compounds. We're not going to do those at all. And we're not going to, I don't think, do hydrates at this time. Could change my mind on that. And we're not going to do with the polyatomics. So the one that you are going to do out of number 20 is potassium iodide. And that's probably it right now. So what's potassium iodide? Potassium iodide. You know it's binary because it ends in "ide." So we need a potassium from here. And iodide comes from iodine, which is here. So potassium's giving one, iodine is taking one. Do we have a match? Yeah, 1 and 1. So we're going to have one of each. So it should be Ki. Number 21, write the names of these compounds. Al2O3, that's binary. Ba in parentheses, ClO, that's barium chlorate. It is not binary. We're not doing that one. SO2, we can do that one. That's binary. NH4Cl, not binary. PCl3, binary. And then the last one's a hydrate. So we've got the first one, Al2O3. It's got aluminum and oxygen. So it is aluminum oxide. Al2O3. Do I have this on another page? There it is, aluminum oxide. That's the only one we can do today. That's okay. Number 22. Nope. We've got SO2. I can do SO2. I can do that one. Well, I got to put it in there. SO2. Let me do that one. SO2. What's that one's name? What's that one's name? That's sulfur dioxide. It's covalent, but it still names the same way. You can't tell from looking at it that I gotta write it this way, sulfur dioxide. You can't tell from looking at it that it's covalent. Now, my chemistry students would be able to figure that out. So you shouldn't have to name that, but if they're simple enough, sometimes they name the same way. Okay, can't find my marker. It's probably where it belongs, that's the problem. Yeah, can't find stuff when it's where it belongs. Okay? Sulfur dioxide. The next one, question 22. Determine the oxidation number of each atom in the following compounds: sodium chloride and iron 3 oxide. Okay, sodium chloride, sodium is here. So its oxidation number, if I go back to the, it's right here, I can pull this one up. Sodium's oxidation number is 1, positive. Chloride's oxidation number, chlorine's here, it's 1 minus. So Na, 1 positive, Cl, 1 minus. Iron 2 oxide, they're telling you with that 2 what iron's oxidation number is. This means that it's 2. And oxygen is in the -2 column. So why don't they tell you what oxygen is? Well, they do, because it's in this column. But iron is a transition metal, so we have to tell you what the iron oxidation number is, or you have to be able to figure it out from what's there. Okay, number 23. I think I'm going to go ahead and take this back off here because it is covalent. Even though we can name it. 23. Explain whether sodium and potassium will react to form a bond with each other. Well, one's on the left trying to give 1 electron. One's on the right trying to take an electron. Oh yeah, they'll react. They'll react quite strongly and release a lot of energy. They combine. To make metallic bonds in an alloy, but they don't. Oh, wait a minute. No, sodium and potassium. You asked me about this, I'll put them together. This is cool. Watch a YouTube video on it. Putting sodium and potassium together. They melt together, kind of. It's weird. No, they don't react. I was mistaken. I was thinking it was sodium and chlorine or potassium and chlorine. They're both in the first column. They make an alloy. They're both metals. So, watch a YouTube video on it. The YouTube videos are better than what I can do in here. They don't react. They don't have a chemical reaction. They're in a homogeneous mixture. They make an alloy. Just if you YouTube sodium and potassium, there's people that mix them. I've seen the videos. Okay, you can't do number 24 right now because it's about polyatomic ions. So let's go practice naming some binaries. What do you get if you put K with Br? And I want this as part of your assignment. Well, K's here in the give one column. Br's here in the take one. What do you get? What's the name? And what's the chemical formula? Potassium bromine. Should be potassium bromide, and it should be 1 apiece because this gives 1, this takes 1. That matches So it's one apiece. Remember, you got to make matches. Okay, next. I want this in your homework. Mg with O. We did this when it burned magnesium over in the fume hood. Mg with O. Mg is here. Gives two valence electrons away. Its oxidation number is 2 positive. Oxygen's over here taking 2 electrons. Its oxidation number is 2 minus. Gives 2, takes 2. Does this match? Yes, it matches. So if it matches, what's the chemical formula? MgO. One of each. And the name is magnesium oxide. These are binary ionic compounds. They're all going to have a second name that ends in "ide." Okay, next one. I want us to practice Ca with N. Calcium and nitrogen. Ca is here, about here, in the 2 positive oxidation number column, giving away 2 valence electrons. Oxygen, I think it was taking 2 and 2 minus. Was that what it was? Ca with N. Nope. So calcium was given 2, combining with N, that takes 3 valence electrons. Oxidation number 3 minus. How do you match 2 with 3? You have to move 6. 3 sets of 2, 2 sets of 3. So there's 3 calciums, 2 nitrogen. And the name is calcium nitride, Ca3 and 2. Next one. If you can do this, you got the binary ionic compounds down, and I'll be happy for the week. You can teach it to chemistry students. Al with S, aluminum with sulfur. Al's here, oxidation number 3 positive, it's right below boron. Gives away 3 valence electrons. Sulfur's here, takes 2. 2 minus oxidation number. How do you make 3 match 2? You have to move 6 again. 2 3s, 3 2s. So it's Al2, S3. And what about Ba with I? Barium gives 2, sulfur takes 1. Sorry, Ba gives 2, right here. Iodine takes 1, not a match. I need another iodine, and the chemical formula is BaI2, and the name is barium iodide. Okay, that's it. We are not going to do binary covalent compounds. They're quite a bit harder. We will try some with polyatomic ions. The covalent compounds, we'll save those for chemistry.